Cura is an OSGI-based application framework for multi-services gateways. Okay, I will explain that after. And as you can see, in fact, before Cura's name was ESF, which is a Eurotech internal name for Everywhere Software Framework. So I will explain that after. Just a few words maybe about Eurotech to explain why we are now releasing this project in Eclipse. So, well, Eurotech is a, we'll forget that. Eurotech is a company which has been working for many years now, more than 20 years, in what we call the embedded world, and building mainly embedded platforms for industrial, transportation and defense, security, and a bit of medical also. So we have a long experience of what we called M2M before. The M2M before was just, we built a platform, a hardware platform, dedicated for some process. And in this platform, we built some software that was getting the data and sending the data or doing something with this data. And this was all in one single process. But you must know that at the beginning, Eurotech was part of the MQTT creation. One guy in Eurotech has been working with one guy in IBM and created the MQTT protocol. And in this time, MQTT has been created because the networks were very slow and they needed a very powerful protocol and very secure protocol. So they built all the MQTT frame. So after that, this guy had in this idea that we should build a kind of Internet of Things, but it was much time before we speak of Internet of Things now. And it took quite a long time because of the hardware that was not enough powerful to embed all these kind of tools inside the devices on the field. But now we reach a time where, okay, we have the power, as we will see in my demo, hopefully. We can embed this in a Raspberry Pi, which is a very small electronic card. And we can address all these type of business now with one single type of application. And that's what is Cura, the basic form for. So just, okay, Eurotech is a global company. Okay, so as many people said before me, Internet of Things is everywhere. Okay, now we need to find a way of addressing all these kind of processes that are obviously one part of Internet of Things. So the starting point of our thinking of the M2M stack is, as we know quite very well, all these kind of application, it starts from the sensors. So on the fields, we have some sensors and actuators or displays. And these data must be sent somewhere for a business application. So in the old time, this was a linear process. We built the sensors, then the gateways and the application, and it was one process. And now we are thinking that with some kind of intelligence in the gateways and some protocols, standard protocols, and with the tools that we have now to send data in the internet, it would be possible to unify all these processes. So the data from the sensors are sent in the same way, whatever was where the data. So this is a small slide to say before we had this kind of problem when we were building an M2M project, because we had to build everything from the sensor to the gateway, then to the gateway to the communication infrastructure, then from the communication infrastructure to the business application and back. So this was many points of failure possible. what we are proposing now is this kind of service. So we have many kind of sensors sending data to some multi-service gateways. And whatever the form of these gateways, all these gateways are in fact running the same process. And this process is just sending data in a broker in the cloud somewhere. And these data are after that made available for whatever customer need these data. So this process is totally unified from the gateway to the consumer. So data are collected and integrated in the multi-service gateway. Then it connects through the M2M protocol, which is in fact MQTT for us, to some kind of integration platform, and after integrated in some business applications. So Cura is just in this part, but we will see that after. So this is a more detailed image. So the multi-service gateway, as you can see, will have all what is needed to collect the data and publish the data somewhere. And all the transport layers needed also. Well, after the M2M integration platform, we'll have the communication broker and a data store layer that will store. This is Eurotech proprietary, the top of the schema. This is our M2M integration platform is something that we call Everywhere Cloud, which is a cloud structure that we use to store, collect the data, store it, and publish it for the consumers. And this, well, we will see that after. Anyway, so communicate is so Open Standard Protocol is MQTT. In fact, the connection is initiated by the device. So when a device connects first to the broker, it sends its ID, and if it is registered somewhere in the database and is allowed to connect to the broker, it will connect, and the broker will be aware that the device is up. The socket is persistent, so there is a very low latency. It's nearly real time. It's very lightweight, as we have seen with MQTT, and the bandwidth is very small also, because also of MQTT, and we are using also some kind of compression of the payloads. This is a publish and subscribe protocol, so we have seen that before. This is secured with an SSL cryptage. This is dedicated? Okay, this is for our broker, and yeah, we will see that after. So the M2M storage is really realized inside our M2M platform, using a combination of SQL for all the information concerning the devices and the users and the access control lists. And the data are stored in a NoSQL database, and we can store huge amount of data. It doesn't make any difference. It is very flexible. So if there is small data, we will have a very small capacity of storage. If we have a lot of data, we will have a high capacity of storage. All that is completely transparent for the user. And secure and available, of course. This is after the acting part. So in our M2M platform, in Everywhere Cloud, we have also a dedicated complex event processing engine. So we can define rules coded in a SQL-like language, and these rules can act automatically on the devices, sending command to the devices, or doing some queries, sending an SMS, sending an alert to somewhere. So all this part is already active and can be used as is in our platform. Okay, and at the end, to access to the data that are stored in our database and managed by the Everywhere Cloud, there is a REST APIs, very standard, that are easy to use for the application integration. So this is another part. So this is the block of Cura. So Cura is mainly an OSGI-based framework. So you can see it's built on Linux, Java, OSGI. Then we have all the device abstraction layer. So the programmer doesn't have to take care of that. If he uses a standard platform that we recommend for this application, he will have everything for the device abstraction layer already done. So he can access the I/O, the modem interface is location is a GPS. If the GPS is present, and the hardware core. Above, we will see after that what is in all the layers. So this is ESF, but remember that ESF and Cura is the same thing. In fact, ESF is the previous name. So as I told you, in the device abstraction, you have the serial, USB, Bluetooth, GPIO, I2C, and other. All these packages are in fact more or less bricks that are already open sourced somewhere. We just build some. We reused some already existing bricks in open source mainly, adapting it when it needed. The gateway basic is just the administration basic service. So there is a watchdog, there is a clock, position when a GPS is available, and all the services managing the process, the bundles that are above these basic services. And the configuration service, very important, that we'll see also. Everything is also in place for network management. So even a device which has enough power can act as a router if we want to combine all the network interfaces. So this is also in place and just needs to be configured. And it included also the connectivity and delivery. It means that it has the Eclipse client, MQTT client inside. So it is able to connect directly to a broker. It just needs also to be configured. This is the management and operation block. So these devices can now be remotely configured, updated, and managed from a web server. I'll show you after that some demo to explain that. And field protocols. Not all the fields are in Cura. In fact, we didn't open source everything because some field protocols are proprietary for Eurotech, but it can be extended as much as you need, because we have the standard Modbus, CAN bus, and Zigbee and this kind of interfaces. And the GUI, there is a web UI giving access to the device configuration, and which is local. The Cura is as inside a local web server, giving access through a web page to the configuration and management of the device locally. I'll show that also after. So now we will enter the demo part. It's the ESF developers Cura developers experience. So we design on a laptop and emulate. When it's okay, we deploy on a target. And when the deployment is done, we can manage the device from the cloud. So we need to switch the... Celui-là, là. tu as après. Oh. Yes, it's okay. Yes, so we are in an Eclipse meeting, so I show you some Eclipse design. Just to show you, so I am trying to program this small greenhouse in which I have temperature, humidity, luminosity sensors, and where I can open or close the door. It's very complicated greenhouse. So, and so I designed a project which name is Greenhouse, and I would like to make it run. So I need, okay, I just have to, yes, to say you that this is using an Arduino platform and an Raspberry Pi as a CPU. But for the moment, the Raspberry Pi is a CPU, and I will connect the Arduino to my laptop just to make sure that my program is running. So hopefully, um, if I can find my mouse, yes. So I will run from here, run as, okay. So this is a script running all parts of OSGI inside Eclipse. And okay, so as you can see, I can get my sensors values, polling Modbus. Oh, okay, I forgot to explain also this is communicating through a serial port with Modbus protocol. So magic, it's getting the value from my greenhouse. So I can then stop that, and after that I will download it to the target. So to download that to the target, what I have done is that I have exported, excuse me, 1 minute, okay. I have exported what is called in Eclipse deployment package, and we are using the deployment service from Eclipse to deploy a package. So I think, no, sorry, it's not very easy. Okay, okay. Okay. So now I am connected to my device, which is the Raspberry Pi here. And as you can see, I have already a web page giving me the possibility to do a lot of things. So I can see all the standard service are running, and the standard service are also configurable. The MQTT broker URL is configurable here. If I want to put there the Eclipse MQTT broker address, it will work the same. I will not do that because I'm not crazy, but it should be. And it's the same for other services. All these services are, in fact, declarative services of Eclipse. I don't know if you have this notion. So they are configurable through XML files, and it's automatically when Eclipse when OSGI, sorry, when OSGI start the services, it automatically starts also the configuration of the services, and it's accessible directly. So this is very powerful. So here we have, so this part is a part of Cura. This is local. This is inside my device. This is a local web server. So we have access to the package installed on my device. Should be. Oh, sorry. Oh yeah, I know. I disconnected it. The demo, famous demo effect. Okay, so what's going on? This one is good. Okay, here I am. Just imagine that here I am on the cloud. I don't know why my web server is not running on my Raspberry Pi. Anyway, let me try again. No. Okay, just 1 minute, sorry. Okay. Okay, this is done. Okay, I need to restart it. So I need a few more time to restart that. So during this time, I will show you something else. Okay, Raspberry Pi is powerful, but not so powerful that it is able to start very quickly. This is the other part of the cloud server. This console is in fact the console that you get when you connect to what we call the everywhere cloud. That is the cloud part of our system. For the moment, it's locally on my laptop, but it should be anywhere in the world. And on this console, you have more than that we have seen on the device, but we have all the data management that is possible. So you can see the data coming in from for each sensor, and you can see the alerts. You can manage the devices, and you can also set some rules to make some action. And this is the main dashboard that gives you the ability to manage all your device on the fields directly from a web page. If we look at the data, so if you look at the data, sorry, okay, we will see the data coming from the greenhouse, and these are in fact MQTT topic. You see here the topic is EDC gas greenhouse sensors, and in this topic we have what we call metrics, which are the values of each sensor in one payload. For the payload of these sensors is filled with these metrics, and we can look at the metrics if we are lucky. For example, the temperature. And we will see all the historical data coming from the sensors. These data are stored in a NoSQL database, and you can, depending on what you need, you can have the history of your data for 1 week or 1 year or many years. Anyway, it's not a problem. It's just a problem of giving more space in the database. We have also this kind of trick is to draw a curve with the data that should be live, but for the moment my device is not ready yet. So I hope it will be soon. So sorry, excuse me, just to make sure. Okay. Whoa. I'm sorry for the demo. Not exactly running as it should. No. See, everything is local inside. I made that to avoid some problems, but unfortunately, I had some problem. It's on a switch, and the two are connected through an Ethernet switch. But should be with a good internet access, we could make the demo with a real broker, but okay. No way. No, I don't know why it's not working. Oh shit. Okay, so I cannot do exactly what I want with my demo. Is it possible to, if I started from Eclipse? Okay. Sorry? No, it's not a problem within. It's a problem with my Raspberry Pi is not starting as it should, and I don't know why. It was working before. It's just a demo effect. Very sorry for that. Where is my mouse? Okay. If I start from there, run as random server. Yeah, okay. Sorry. And after that, we'll see if we can get the data published. Okay, so in this case, so this is a dashboard that I was supposed to work with my Raspberry Pi and to show you that the data are coming in. Apparently, it's not very good also. No, not working. No. Sorry. Okay, just 1 minute. No way. Okay, bad demo. Sorry. Well, in fact, the demo was data comes from the sensor, Raspberry Pi, send the data to the cloud. This application dashboard is running on a server in the cloud, and you access to it through a standard URL, and you have directly in real time. What it was the goal was to show you that it's a real time. You can see the sensor's value, and you can act on the device. When I click on open, it should open the door. But as usual, I had a problem, and it is not working, and I don't know why. So this is the whole process of what we are offering on our system. It's sensors coming from somewhere, sent through a gateway, a multi-service gateway, to a broker, and after that, it's up to you. But in Eurotech, we have the other part, which is everywhere cloud, which is taking the data from the broker, storing it in a NoSQL database, and giving access through a web server to the full management of the devices and to the full management of the data coming from these devices. So this is for one device. This is for thousands of devices. It will be the same, exactly the same process. So from what we have seen today as applications of IoT, nearly everything can be achieved with this kind of system. As soon as you have data coming from sensors and you have some consumer somewhere needing the data, between the two, we are taking care of that. And Cura is the portion of that which will take care of the data locally from the sensors. We'll take the data from the sensors, send it to the cloud, and after that, it's up to you what you want to do. So okay, I will stop that because it's just crap. I will just want to show you a demo that has been working. In fact, yeah, it's finished. Okay. So it was in last June in San Francisco for JavaOne. We set up a large demo of what is possible to do with this system. It was exactly the same kind of system. So we plan to count the people going inside rooms and outside of the rooms, and mainly of the big conference room where 8,000 people were coming in. So we have a device in Eurotech what we call the passenger counter, which is just counting people passing through a door. So they installed these passenger counter on all the doors, giving access to the big room. And during the show, they were, after that, so as you can see, there were a few passenger counter set up at the entrance of the rooms. And during the show, they started to count people. And in real time, the data coming through the cloud. So it's exactly the same thing that I wanted to show you, but in a larger scale, were taken by another partner who drew the dashboard, and you could see in real time people coming in and coming out. And it was quite very impressive because even the guys in JavaOne has never imagined that they could do something with that. And everybody was very impressed that you could see in real time that the main room was crowded, or everyone were getting out, and there has been a very funny thing that when Larry Ellison was supposed to come to talk, in fact there was America's Cup, and he didn't come. So the full conference room was really full, and when the speaker said, "No, Larry will not come, but we have this guy who will speak in place of Larry," and 2/3 of the room just empty at the same time. So we could see the curve is just dropping. It was absolutely crazy. So this is a working demo of what I wanted to show you. Okay, thank you.